ancient technology scientists still can't explain ancient aliens' evidence. History is usually presented as a straight line, a steady climb from ignorance to knowledge, from crude tools to advanced machines, from superstition to science. We're taught that ancient civilizations did the best they could with what little they knew, and that modern science represents the peak of human understanding. But every so often, something surfaces that doesn't fit that narrative. An object, a structure, a level of precision that seems wildly out of place. And when those anomalies appear, the story of progress starts to feel less certain and more incomplete. Across the world, archaeologists and scientists have uncovered artifacts that seem to exist outside their proper place in time. These are not vague legends or symbolic carvings. They're physical objects you can measure, analyze, and test. They display accuracy, symmetry, and complexity that, according to conventional timelines, should not have been possible. When confronted with these discoveries, the usual explanations begin to strain. The materials are too hard. The tolerances are too fine. The results look less like trial and error and more like deliberate engineering. What makes these artifacts so unsettling is not just what they are, but what they imply. If ancient cultures truly lacked advanced knowledge, then how did they produce results that rival or even surpass certain modern techniques? And if they did possess that knowledge, where did it come from? And why does it appear to vanish from the historical record? These questions don't just challenge archaeology. They challenge the foundation of how we understand human capability itself. Modern science prides itself on evidence, replication, and peer review. Yet even within academic circles, there are moments of quiet admission when experts encounter objects they cannot easily explain. Instead of clear answers, there are phrases like anomalous, unusual, or not yet understood. These are careful words, but behind them lies a deeper discomfort. Because to fully explain some of these discoveries would require rewriting parts of history that have long been considered settled. This is where the tension begins. On one side is the traditional model of gradual technological evolution. On the other is physical evidence that seems to skip steps, appearing suddenly with no obvious developmental predecessors. In many cases, there are no crude prototypes, no experimental failures, no visible learning curve. Just finished results, executed with confidence and precision. For scientists trained to look for incremental progress, that absence is deeply problematic. The instinctive response is often to minimize the mystery. Perhaps the dating is wrong. Perhaps the object had a ceremonial purpose rather than a functional one. Perhaps the ancients simply had more time and manpower than we imagine. These explanations can sound reasonable at first, but they often collapse under closer scrutiny. Time does not create precision on its own. Manpower does not automatically produce accuracy. And symbolic intent does not explain measurable, repeatable technical features. What's rarely discussed openly is how threatening these questions can feel. If ancient civilizations were capable of achievements we still struggle to replicate, then modern humans are not the unquestioned pinnacle of intelligence we assume ourselves to be. That realization touches something deeper than academic debate. It challenges identity. It forces us to confront the possibility that knowledge can be lost, it's not just gained, and that progress is not guaranteed to move in one direction. There is also a subtle shift in perspective that occurs when you take these anomalies seriously. Instead of viewing ancient people as primitive ancestors fumbling in the dark, you begin to see them as observers, experimenters, and innovators operating within a framework we no longer fully understand. Their worldview may have been different, but different does not mean inferior. In some cases, it may have allowed them to notice patterns and possibilities modern thinking overlooks. This is where curiosity turns into quiet rebellion. Not rebellion against science itself, but against the idea that science already has all the important answers. The most honest scientists will tell you that uncertainty is not a weakness of science, but its engine. Every major breakthrough began with someone admitting, "We don't know." The problem arises when that admission is avoided, when anomalies are sidelined because they don't fit comfortably into existing models. These out-of-place technologies act like loose threads in a tightly woven story. You can ignore them for a while, but once you start pulling, the larger pattern begins to shift. Questions multiply. If one ancient artifact defies explanation, how many others have been misinterpreted or overlooked? How much of what we label as myth or ritual was actually practical knowledge expressed through a different language? And how many assumptions about the past are based more on expectation than evidence? Importantly, this inquiry does not require leaping to wild conclusions. It doesn't demand that we immediately replace one rigid story with another. The goal is far more subtle and far more powerful. It is to create space for doubt, to allow uncertainty back into a narrative that has become overly confident. To recognize that not knowing is sometimes more honest than forcing an answer. By destabilizing certainty, we open the door to deeper investigation. We give ourselves permission to look again at old evidence with new eyes. We begin to ask better questions, rather than settling for convenient explanations. And in doing so, we honor the very spirit of scientific inquiry we claim to value. This is only the beginning of that process. The artifacts exist. The measurements are real. The contradictions are documented. What remains unresolved is how far these anomalies extend and what they ultimately reveal about humanity's past. The evidence does not shout its meaning. It waits patiently, challenging anyone willing to look closely enough to admit that the story of ancient technology may be far more complex than we were ever taught. When you begin to examine ancient artifacts closely, the mystery stops being abstract and becomes physical. It's no longer about legends or interpretations, but about stone, weight, hardness, and measurable precision. Across multiple ancient sites, researchers have found cuts so straight, surfaces so flat, and angles so consistent that they resemble the output of modern machinery rather than hand tools. These are not isolated curiosities. They appear again and again, carved into some of the hardest materials found in nature. Granite, diorite, and basalt are unforgiving substances. Even today, shaping them efficiently requires hardened steel, diamond-tipped blades, controlled pressure, and stable power sources. Yet mainstream archaeology maintains that ancient builders worked these materials using copper chisels, stone hammers, wooden mallets, and abrasive sand. On paper, the explanation sounds plausible. In practice, it immediately begins to unravel when the results are examined under magnification. Some ancient drill holes display spiraled striations that descend at a consistent rate, as if produced by a rotating tool under steady feed pressure. In modern machining, this pattern is familiar. It indicates a controlled mechanical process, not random abrasion. When engineers attempt to replicate these marks using reconstructed ancient methods, the results simply do not match. The surfaces are rougher, the grooves are inconsistent. The depth progression is uneven. The comparison raises a difficult question. If the tools were primitive, why are the results so refined? Then there are the stone boxes, perfectly squared interiors carved from single blocks of granite, with internal corners sharper than what many modern cutting techniques can easily achieve. These boxes often show flatness deviations measured in fractions of a millimeter. That level of accuracy is not accidental. It requires planning, measurement, and repeatability. Time alone does not create precision. Labor alone does not explain consistency. Something else had to be guiding the process. Machinists who examine these artifacts tend to notice details others overlook. They look for tool chatter, feed marks, slips, and undercuts. In multiple ancient objects, they find patterns that resemble mistakes made by machines, not by hands. Slight overruns, uniform tool paths, abrupt terminations that suggest a rigid cutting edge rather than a flexible abrasive process. These observations are uncomfortable because they point toward techniques that should not have existed at the time. Faced with this contradiction, the usual response is to redefine the problem. The artifacts are labeled ceremonial. The precision is described as coincidental. The measurements are dismissed as overinterpretation. But this strategy only works until enough examples are stacked side by side. One anomaly can be ignored. 10 begin to raise eyebrows. Hundreds demand explanation. Evidence stacking is relentless because each new discovery reinforces the same core inconsistency between accepted tools and observed results. What makes this especially troubling is that these features appear across different civilizations separated by vast distances and time periods. The same types of cuts, the same material choices, the same obsession with smoothness and symmetry. This repetition suggests shared knowledge or convergent techniques, neither of which fits comfortably within conventional historical models. It implies that something systematic was at work, not a series of lucky accidents. Laboratory analysis deepens the puzzle. Microscopic inspection reveals surface finishes comparable to those produced by rotary machining. In some cases, the rate of material removal implied by the tool marks would require forces far beyond what hand-powered methods could sustain. When engineers calculate the torque, pressure, stability needed to achieve such results, the numbers refuse to cooperate with traditional explanations. The math simply doesn't align with the narrative. At this point, the question, "How was this done?" stops being rhetorical. It becomes unavoidable. Every attempt to answer it using accepted assumptions introduces new problems instead of resolving old ones. The harder researchers try to force these artifacts into a primitive framework, the more strained the explanations become. What was once described as simple ingenuity begins to look like technical capability we no longer recognize. This does not mean that ancient people were identical to modern engineers, or that they followed the same technological path. It suggests something more nuanced and more unsettling. They may have approached materials differently. They may have prioritized methods we abandoned or never rediscovered. Their understanding of stone, vibration, pressure, or abrasion could have been based on principles lost to time, not because they were inferior, but because knowledge is fragile. Precision leaves fingerprints. It records intent. And when that intent appears repeatedly in stone harder than steel, it forces us to confront an uncomfortable possibility. The tools of the past may not have been as simple as we were taught. Science struggles here, not because the evidence is weak, but because the implications are strong. To acknowledge the full weight of these artifacts is to admit that our picture of ancient technology is incomplete, and that the line between primitive and advanced is far blurrier than history books suggest. Among the most unsettling discoveries are machines where no machines should exist. Not symbolic objects or ceremonial tools, but mechanical devices with gears, ratios, and calibrated components designed to perform specific functions. These artifacts don't hint at experimentation. They suggest mastery. They appear fully formed, as if the knowledge required to build them arrives suddenly. Without the long chain of trial, error, and refinement that defines progress, what makes these devices difficult to place in history is their sophistication. Interlocking gears cut to precise tolerances, components designed to move in predictable cycles, and systems capable of modeling natural phenomena. Compared to modern mechanical engineering, the logic is recognizable. The language is different, but the principles are the same. Motion becomes calculation. Rotation becomes prediction. According to accepted timelines, the societies that produce these mechanisms should not have possessed the mathematical frameworks or fabrication techniques required to create them. There are no earlier prototypes showing gradual improvement, no crude predecessors leading to war complexity. Instead, these devices emerge as anomalies, seemingly out of nowhere. This temporal displacement troubles conventional history. Advanced machinery is supposed to evolve, not appear abruptly. When engineers examine these artifacts, they recognize design choices still used today. That recognition creates a question. If ancient builders understood these principles, What else did they know that has since been lost? The mystery deepens when attention shifts from machines to energy itself. Mechanical precision is one thing, but controlled power is something else entirely. Across ancient sites, researchers encounter evidence that suggests deliberate illumination and energy use in places where fires should have left unmistakable traces. Yet ceilings remain clean, walls unblackened, and enclosed chambers show no signs of smoke or residue. The contradiction is immediate and unsettling. Mainstream explanations often rely on torches or oil lamps, but these ideas collapse under basic physical scrutiny. Combustion requires oxygen, and many of these chambers are sealed, narrow, and poorly ventilated. Sustained flame would have consumed breathable air quickly, leaving behind soot and scorching. Instead, surfaces appear pristine, as though light was present without heat or smoke. When one explanation fails, another is proposed, but each is eliminated by the same stubborn evidence. Reliefs and artifacts add to the unease. Certain carvings depict elongated objects connected to what look like power sources, cables, or containment vessels. Interpreted symbolically, they are dismissed as myth. Interpreted literally, they resemble controlled energy systems. This tension creates a gap where conventional archaeology hesitates to tread. Because acknowledging the possibility of advanced energy use would destabilize established timelines, objects such as primitive batteries intensify the problem. When reconstructed using simple materials, they demonstrably produce electrical current. Scholars may debate their intended purpose, but the function itself is undeniable. Electricity exists where it should not. The question shifts from whether ancient people could generate power to why they would need it. Each unanswered detail reinforces the same conclusion. Something is missing from the official story. Science is forced into a defensive posture, explaining why something cannot be true rather than explaining what is actually observed. That reversal is revealing. It suggests not that the past was magical, but that it may have been technological in ways we no longer expect, pushing the mystery further into territory modern explanations struggle to illuminate. And each contradiction, certainty, erodes a little more. Sound is often treated as decoration in ancient history, something added to ritual for atmosphere or emotion. But when you step inside certain ancient chambers, that assumption becomes difficult to maintain. The air feels different. Your voice behaves differently. A single tone can linger, swell, and return to you altered, as if the space itself is responding. This is not coincidence. It is design. Across continents and cultures, researchers have identified structures carved or built with an exactness that allows sound to behave in highly specific ways. Narrow passages amplify low frequencies. Rounded chambers concentrate vibration. Stone surfaces reflect waves with minimal loss. When measured, these spaces repeatedly resonate at frequencies known to affect the human nervous system. You don't just hear the sound. You feel it moving through your chest, your bones, your breath. Modern science calls this resonance. When an external frequency matches the natural frequency of an object, energy transfer becomes dramatically more efficient. In enclosed spaces, resonance can amplify sound far beyond its source. Neuroscience adds another layer. Certain frequencies can entrain the brain, nudging neural activity toward altered states of awareness: calm, focus, trance. These effects are measurable, repeatable, and well documented today. What unsettles researchers is how consistently ancient sites exhibit these properties. From underground chambers to stone circles to temple halls, the same frequency ranges appear again and again. This repetition suggests intention, not accident. These builders may not have used modern terminology, but they understood cause and effect. They shaped stone in ways that turned sound into a tool. In this context, chanting and music take on a different meaning. They are no longer symbolic gestures toward the divine, but activation methods, inputs designed to interact with architecture. The human body becomes part of the system, responding to vibration as much as the stone itself. This reframing blurs the line between technology and ritual, matter and energy. Once sound is understood this way, earlier mysteries begin to align. Precision stonework, energy anomalies, and mechanical skill converge toward a deeper principle: control of vibration. Not brute force, but resonance. It's not domination of nature, but cooperation with its rules. The idea is subtle, but profound. Ancient technology may not have been louder or stronger than ours, but more attuned. And that possibility forces a quiet reconsideration of what advance really means. It invites us to listen and question what knowledge we may have forgotten. At a certain point, the evidence stops pointing outward and begins turning inward. If sound, vibration, and architecture were carefully engineered, then the human mind may not have been a passive observer, but an active component. Across ancient cultures, figures we now label shamans were not simply spiritual leaders. They were operators, trained to enter altered states of consciousness with precision and control. Ritual sound, rhythmic drumming, chanting, and breathwork were not random expressions of belief. Modern neuroscience shows that rhythm and frequency can entrain brainwaves, shifting awareness from analytical states into focused or trance-like modes. These shifts are measurable, reproducible, and deeply physiological. The brain synchronizes, perception changes. Sensory boundaries soften. When ancient texts describe voices, visions, or contact with unseen realms, the language sounds mystical, but the mechanisms align with known neural processes. Consciousness becomes an interface. The body responds to vibration. The mind interprets signals differently. What was once called magic begins to resemble a sophisticated understanding of human cognition, discovered empirically rather than theoretically. This reframing alters identity. Ancient people were not worshiping blindly. They were participating. Their technologies may not have relied on switches or screens, but on attention, intention, and neurological states. Such systems would leave little physical evidence, making them easy to dismiss. Speculation remains grounded. Yet if consciousness can be altered predictably, it becomes usable technology, internal, transferable, and easily forgotten today. What emerges after examining all of this is not an answer, but a shift in perspective. The technologies hinted at in the ancient world do not sit comfortably within modern categories, and that may be the point. We tend to measure advancement by speed, power, and scale. Yet the past seems to whisper about something different, about knowledge tuned to materials, environments, and the human mind itself. If that is true, then nothing may have been lost in the dramatic sense we imagine. Instead, certain ways of understanding may have simply fallen out of alignment with how modern civilization thinks. Progress narrowed our focus. Efficiency replaced sensitivity. Measurement replaced experience. In that transition, subtle systems may have become invisible rather than impossible. This possibility demands humility. Suggests that rediscovery might not come from building bigger machines or faster computers, but from learning to ask different questions, from noticing patterns we were trained to ignore, from accepting that intelligence can take forms that do not leave obvious footprints. The mystery, then, remains open by necessity. Not because the past is unknowable, but because our perspective may still be incomplete. If ancient technology was rooted in perception as much as production,